Okay, we want to take a look here at the led.c file and look at how it implements the led.h file. As you recall, in the led.h file, we declare these three functions, prototype them so that anybody who wants to use our functions in the led file can just include the .h file and have access to the prototypes so that the compiler knows how to compile their file separately without having to see all of our implementation. The implementation, however, is placed in the led.c file. So notice at the very top of the led.c file, there's an include of led.h. Notice the quotes around the led, I can't even say led. The quotes around the led.h file here are the same include operation. The quotes just mean look for the led file, .h file in the same directory in which you find the led.c file. If it had the brackets, remember it would start searching through the compiler's include path, and that's where the system files are. But when we create our own .h files, we keep them in our local area, and we use the quotes to tell the compiler find it in our area here. So we're down in our prototypes. Here's the default one. I'm going to put these three functions in here right now and just turn them into functions. And then I'll take this, our separator line for functions, put it in there, and there. Okay. So now I've declared our functions that match the prototypes. And we have our include up here to pick up the prototypes, so we're ready to go. The first thing we'll look at is the led init function. And I'm going to copy this from what I've already done to save the time. And we'll see what I've got here. Notice that I've got some comments up front. They just tell the user where the R0, G0, B0 LEDs are. So we remember that these three were PWMable pins. I just marked those as such, but they're actually at PD5, PD6, and PB1. G1 is at PB2, and then R1 and B1 are at these locations. If you look at port B, the LEDs, it's got G1, B0, B1 on the bottom three pins of port B. And port D has G0, R0, and R1 up here at pins 6, 5, and 4 of port D. So that helps us explain what's getting ready to come, because what I want to do now is make sure that these pins are all outputs and that the outputs are set to 0 initially. So the first thing I do is turn off the outputs, and that's incorrect. That needs to be a tilde. So port B is turned off at the beginning, and port D is turned off at the beginning. And then set the initial direction for each of these to be output. So if you're looking at a 0, x0 to 7, that's the same thing as 0b, 0, 0, 0, 0, 0, 1, 1, 1. Right, so we're turning on those bits to be outputs, and then we're making sure those bits are turned off in the output. All right, so that's the init. Every function we're going to have is going to have every driver will have an init function on it. And notice how this is careful to not hit any of the bits that are not in use. All these dashes, it just leaves them alone. We don't know what other drivers may use those pins, so we don't want just to slap a 0 in there, just to write these to default them to 0, because if somebody else had set those up to be outputs, we would just turn those back to inputs. So we want to be real careful about only controlling our pins. All right. The LED set function, I'm writing in a very simple way here. What I want to do is just make sure, figure out which button it is, or which LED, has been sent in. And then if the LED is equal to 0, then I need to call the appropriate, oops, that was wrong. Then I want to call a different function I haven't written yet, called LED0set. We'll pass the value down to it. Now this is already incorrect from what we've got in our style guide. This should read 0 equal LED. And And then if it's not that, I want to do an LED1 set value. All right. In my code, I also did this where I'll do this. I'll just make sure that if somebody passed me stuff that's invalid, I get rid of it. All right, because I can only this function can only take 3 bits in the value, the RGB bits. So I just mask off anything that might have been sent there. In this particular case, it may not be necessary if no one looks at it, but it's kind of a good habit for a lot of functions. All right, and that's the comment here. And that would then call our correct functions. However, we haven't written these functions yet. We're making these local functions, or private to this routine. So I've got an LED0 set value. Well, I need to come down here into my private area and create a void LED0 set value, where value is also a uint 8_t. Now, since this has already been used up here, the compiler has already seen it, and C will default this to an int. So a function that returns an int. And then when it sees this, it'll give you an error because it up here defaulted it to be a function that returns an int, and now it's a function that returns a void, so now there's a name collision. So what you want to do up here is always declare all your functions that are private in your prototype section. There, now that's declared. Additionally, we want to do one more feature, that's to keep LED0 set from being seen from anybody outside because it's a private function. So we use the keyword static, which when applied to a function means that it cannot be seen from any other file. It can only be seen from this file that we're in. So other files could have LED0 sets that are static that don't name collide with this one. All right, and I'll go ahead and add that static word back down here. I'm not certain that you need to, but I like it. Okay. Now what happens in here is the actual setting of the LED, which again is unique to this particular function. It's going to be the exact bit, so I'm going to copy that as well and stick that in here. Let's look at that real quick. Here I'm going to look at value R0, G0, B0. That's what I'm looking at on LED 0. All right, so I'll look at these R0, G0, B0 pins. And I'm going to take the value coming in that again was either red, green, blue. And if it's 0, 4, again, those of you who aren't used to hex should get used to hex because you'll see this very frequently. People will not, you don't see the 0B as often as you see the hex. So you know that 4 is this bit right here. So we're saying if the red bit is on, well, in that case, turn on that red LED, otherwise turn off the LED. Well, the red LED is at PD5, so I'm taking port D and OR equaling with 1 left shift 5. Well, what does that do? This is the same thing as writing port D equals port D or 1 left shift 5. Okay, that's what the OR equal does. It's just a shortcut nomenclature to say OR this value into this register, or read, modify, write. And then the 1 left shift 5 is simply taking a 1, which would be that value, and left shifting it 5, which would be that value. You could have written 0x20 instead of 1 left shift 5. People do different things. This seems clear to me because I'm saying I want you to take the 5th bit, or bit 5, and set it to a 1. All right. And then otherwise, and equal with the inverse. Remember, when you turn a bit on, you OR equal that bit. You OR a bit to turn the bit on. You AND with the inverse to turn the bits off. All right, and we can see that if it's the green LED, same thing here, or a value, find that, and then turn the green LED on or turn it off. It's the blue LED, turn the blue LED on or off. All right. So that's our LED 0 set function. I'm going to put a comment up at the top of this, just so we know what's going on. Again, just to explain, there's our guys clearly. Turn on or off the appropriate LEDs, and I might say value is expected to be 0 tick 0 0 b 2 3 4 5 RGB, which I think I set up here. Maybe I didn't. Probably should have. Yes. In my example code that I sent out, I did the same thing up here. Something similar. Okay, so there's our RGB 0 code, or LED 0 set. I need to do the same thing now for LED 1 set. And I'll copy that code. And we can see, again, identify the LEDs and do the same functions down here. LED red 1, that's a typo, that should be green 1. And that should be blue 1. See where I copied comments and made a mistake. Okay, and that's our LED 0 set. Now I also need to go back up here to my prototypes and put in an LED 1 set. Okay, so now I've made two private functions, static LED 0 set, LED 1 set, that you can call from within this file, but not within another file. All right, finally, I'd like to create one more function. If you go in the led.h, if you remember, I had the LED set value. When I go to rotate the LEDs, I'd like to write all 6 LEDs at once, and I can't do that with this LED set function. Just focus on RGB 0 or RGB 1. So we will go to this LED set value function, and all we're going to do here is take essentially the amalgam of both of the functions and just stick it straight in. Right, so here I'm going to take, here's all 6 LEDs, and I'm essentially just copying that code directly. Another way to do it would be to take the value, mask off the bottom 3 bits, and call button 0, then shift it down 3, and then call button 1. I mean, not buttons, but LED 0 and LED 1. You could do that as well. But I just chose to copy it straight in. It's not that big of a code. All right, so different ways to do it, but at the end of the day, very simple interface here with some important details. Again, when you initialize, only set up your particular bits. And again, these are coming, as you recall, out of the dependencies. Right, IOM 3328p, the .h file for that, and these are all defined in there. So one of the nice features about the IDE is you can come in here if you need TCCR00A, as it starts to fill them in for you. So that's pretty handy. Okay, so that's the led.c file ready to go.